an individual effort. It's really a team activity. And if you go into our organizations, you actually see, I think, a disproportionate amount of this, single chemist sitting in front of a PC trying to make decisions, and not enough of the right-hand side where teams can actually work together on a problem and make decisions as a team. And I think the issue here, one of the issues, and now here we return to the cloud, is if you explore a problem with a team, you potentially avoid some of these prejudices and issues that you would get with decision-making as an individual. So, of course, if you have several people contributing, the politics, the previous experiences, the short-term goals may be diluted. I think the other thing, and you'll know this kind of parable, if you take 3 blinded people and you ask them to assess what this animal is, and they have limited ability to interact with this animal, you'll get some different responses. So one will say it's a walrus, another a snake, another it's clearly a tortoise of some sort. And of course, the animal that they're looking at is an elephant, but they each kind of have a little piece of the animal, whether that's the tusk or the trunk or just the skin. And again, if you enable a team to come together, you avoid some of those issues with incomplete coverage or lack of knowledge that resides within each individual. So what we've been working on is a team interface, a multi-touch team interface that really enables team decision-making and also enables us to work with much more complex data than we would be able to do with on a PC. And I'm going to show a little video. And these are the stars of the project and also the stars of the video. Okay, so here you see a couple of our chemists interacting with, this is a Perceptive pixel wall, multi-touch wall. They're working with these compounds, and this is based on a use case that we identified where chemists were working with compounds on paper cards. So we kind of replicated this card shuffler. They're applying different types of filters, property-based filters. So some compounds are displayed, some are grayed out. They're able to make some selections, take the compounds into a kind of another working area. In this case, they might want to look perhaps a little more detail at some of the properties. So here you see a little star chart of the Lipinski rules, the druggability kind of things, C log P, H1 donors acceptors, and so on. So they can explore. These are getting data live from the database, by the way. They can drag a lens over the top of their data. So in this case, the compounds are sitting under a lens, and they can apply different filters. You can have multiple lenses, actually, and different ways. So some of the compounds are then returned back to the pool. 2 compounds are kind of kept, and they've gone on to now another pair of scientists, 2 scientists looking at the molecular design aspects. So they can overlay compounds. They can, in this case, now going to annotate some of the compounds. So they can draw onto the cards in the same way a chemist would draw on a paper card. So this is an HTS hit. This is a known compound, perhaps from the literature. They can compare the compounds. They can start to make modifications. And I think you'll see these are all things you could potentially do on paper, but the way that the scientists are able to interact with this introduces actually a very different way of thinking and also the ability to work as a team. So finally, as they start to establish their kind of design ideas, introducing this hydrogen bonded structure here, they can perhaps annotate this for the project team. So they're going to send this off to the project team for synthesis. If they're not happy with the annotations that they've made, they can kind of scroll backwards and forwards, as you'll see in a moment, just by running finger across the card. Okay. And so Torsten here has created a new container, a new card pile, and he can sort of vacuum up the cards into the card pile. And this could equally be clinical images. They could be any type of data. So it's a proof of concept of how one can interact with data in a different way, in a different environment. So now we're going to connect, we're going to label the container decisions and pull up, next step, pull up the project team. So there's little avatars of the project team members. And they're going to email there we go. Going to email the content of that off to the project team. And the project team will also see a snapshot of the decision wall at the time it was sent. So this is the second use case. This is really thinking, how do we work with semantically rich and semantically integrated data? So I think you'll all be aware working with this stuff on a PC is very difficult. So here in this environment, we can have potentially very complex, very large data sets that are semantically or otherwise integrated. And in this case, we're looking at genes, diseases, compounds. And we have the ability, you'll see on this, this network, this graph on the right, as Torsten here, has the potential to remove or add certain types of relationships. So you could imagine, for example, I just want to now cut the relationships that are deriving their information from non-human sources. So all animal-based or in vitro-based systems are removed, and only human data remains. And then you can see the decomposition of the network. And I think this is a hugely powerful way of interacting with these types of data. You see now self-organizing approaches, complex data here, and the ability to visualize potentially where you get nodes here. So you have if this is a compound or a gene, perhaps, that's connecting several different clusters of information together. So I think you kind of get the feel for it. This is a very different way, potentially, of interacting with information, and to do that in a way which you can do with colleagues in a team. So I could only show a very short snippet of this, but if you want to see more of this, Steve Guys is going to be presenting after lunch in the drug discovery informatics stream. So he's going to go into a lot of detail about this particular project, and it's also available for hands-on, a slightly smaller version at the Acceleris booth in the, I think it's in the 400 lane of the exhibition. So just to wrap up, in summary, so some thoughts, some takeaway thoughts. I think if we can minimize reductionism by our scientists, we'll be making a significant contribution to the decision activities of the organization. We should be investing where there's most value, and I think this is a big question that we will be discussing, I'm sure, together for some time. We want, of course, integrated data, seamless flows. We need support for semantic-based questions, more natural language-based questions, support for ideation and annotation, decision capture and sharing, so we can actually learn from previous decisions that have been either successful or not successful. We want more intelligent interfaces, so the Watson or the Wolfram Alpha type of support for decision making. So scientists can be supported, maybe contextually relevant suggestions are made by systems. And finally, we want the ability to explore data that allows scientists to browse the universe of information and to collaborate as a team, both remotely and locally. So this is, I think, the focus of what we would like to move to. So we looked at the vision, the mission of our organization, and of course it's a journey that we're on. We're far from complete. But when I really think about it and boil it down, it's all about decision support. So I think if we're going to be successful as an industry, if we're going to be successful as our contribution of scientific informaticians, we should be thinking about the stronger support of decisions that enable differentiated, highly effective medicines, and not just efficient ways of working. So the final thought I leave you with, and this is really, I guess, at the heart of the problem, if we always do what we've always done, we will always get what we've always got. And you can think of some exceptions, but broadly that's true. If we just keep doing what we've always done, we will continue to fail to meet our objectives to deliver medicines to patients that need them, number one, and also, secondly, to deliver financially to our various stakeholders. And this quote appears in various forms from Henry Ford again. Albert Einstein said something very similar and attributed to a number of other people. But I would add this little thing at the bottom. So we'll always get what we've always got, even if we get it a little bit faster and a little bit cheaper. We will still not be successful. So I'd like to thank you, of course, for listening, and also the team that's behind everything you've heard here. So Roche's Pharma Research Early Development Informatics team. And with that, I would be happy to take your questions or discussion.
Okay, we're running tight on time, but we do have time for at least one question.
It was a nice and interesting talk. Thank you. I was just wondering about, over here, just wondering about what you were saying, that the last quote, and also about these systems. And do you think that this, the intelligent computer systems, will they ever be able to think outside the box? That is, I mean, they're basing their decisions on knowledge that we have. But what about completely new ideas? Will they come up with new ideas and new answers?
It's a really good question. I think The first step is, from my thinking, the first step is to enable scientists to kind of get to grips with what we already have and to work in a similar, perhaps a similar way than we have before. But I think the potential is absolutely there to seed them with the ability to make different decisions. So if you add some sort of more evolutionary type aspects to those systems, I think there is a potential to introduce not an element of randomness, but of a sense of perhaps forcing it down different potential hypotheses and exploring those to a certain conclusion and maybe presenting them back. So I think there is that possibility, yeah.
I was going to ask you a question about how do you measure your hits as far as the organisation is concerned in terms of supporting good decisions? Do you get feedback from people to say that hadn't been for your system, I wouldn't have thought of that particular way to go forward?
Yeah, it's a really good question. Absolutely. So the question for those who didn't hear was, how do we measure our success in terms of supporting decision-making? And I think the answer at the moment is with very great difficulty. So it's mainly anecdotal at the moment. What we'd like to do with the Perceptive Pixel project, the multi-touch project, is we're actually working with an academic collaboration who have a lot of expertise and who have the potential to really objectivize and measure the changed working of the scientists in that environment versus their normal environment or their traditional environment. Because we're very conscious we can make it look cool, and the scientists love to work with it, but objectively, how does decision-making change when they work in this environment? And we're still to actually make that measurable. But it's high on our agenda. We would very much like to do that. Yeah, that's another, even if we introduce these technologies, the question is, how do we, I guess, enable the scientists to work with them? I think actually it requires a huge change. It requires a different breed of scientist, a different way of thinking. And I think one of the challenges is actually training and developing the scientists in line with what we have the potential to do here. And that's one of the challenges of this avoiding reductionism. How do we help scientists to make best advantage of the approaches that we can deliver? And I don't have an answer for you. I think the challenge is huge, and I think education and training is the first step. And the first thing that we're doing internally is just to raise awareness of what's possible, and then engage with some of those, if you like, thought leaders to try and bring that into the organization. But it's very difficult because people don't necessarily appreciate the issues that they have.
Okay, thank you.